Hi everybody, this is Mr. Beckstrom, and I'd like to do an example from section 6.1. This is an arc length problem, and it says find the central angle theta which subtends the arc length of length 41 feet of a circle of radius 36 feet. So what I'm going to do with this one here is do ink to shape, see if I can get a decent circle in here. Let's see if it'll draw me a circle if I do. Hey, look at that. All right, turn that back off here. And so if I were to draw a center point there and then go ahead and draw a couple of lines there. Let's see. I don't really need to be too exact here, but let's just say it looks something like this. Get rid of that here. And so what am I looking out for? So the radius is 36 feet. So this distance here is going to be 36 here. That's the distance from the center out to the point on the outside of the circle. And the distance 41, I realize this is not drawn to scale, is going to be the distance from here to here. So this is going to be 41 here. That's the arc length. We're trying to find the central angle here. So this is going to be our theta there that we're trying to find. And I think this is pretty much it. So this is what we're looking at. Now, in the book, it's on page 367. Now, remember, when we're doing the arc length and we're doing that angular speed, and also the other one here, which is the what's that last one that we're doing? The angular velocity. Sorry, I meant the linear speed. So when we're doing those, these are all going to be in terms of the radians, so we have to kind of keep that in mind. Now for this problem here, I'm going to go ahead and find this theta, both first in terms of radians, and then I'm going to go ahead and find that in terms of degrees, just so we can do it in both. That's good practice here. So in terms of radians, my formula is this. It's S, which is the arc length, is equal to the radius times the central angle theta. Alright, so in this case my arc length is 41 and my radius is equal to 36 and my theta is my unknown. That's what I'm trying to find here. Oh, let me turn my ink to shape off here so I don't do that. Alright. So I divide both sides by 36 to solve for my theta. I'm going to get 41 over 36, 41 over 36. And for the radians, I'll go ahead and go out 3 decimal places. So actually, let me draw it like this. So this is approximately equal to 41 divided by 36, 41 divided by 36, and that would be 1.139 radians. So we could write it like this, 1.139, and you just put RAD for radians, and that would be our answer there. If they asked us to the thousandth place or to 3 decimal places, put it like that. Now if we wanted to convert that to degrees, I'd probably just leave it in my calculator like this. And remember, if we want to convert to degrees, we would multiply by 180 degrees over pi. We put the pi on the bottom so those radians kind of cancel out there. And I could just do it in here, so I could say times, and in parentheses I'm going to put 180, divided by pi. So you can just state divided by second over pi like this. I just leave it in there so I can use all those good decimal places there so I get a nice accurate answer. And I will round that to 3 decimal places as well. So 65.254. So this is also approximately 65.254. 65.254 degrees. All right, so I hope this helps with this one. If you have any questions, please put them in the forums, and I hope you have a great rest of the week. Thanks.